start recording here. And share the screen. Oh, wrong screen. This is better. Okay, so the quiz, this is what's going to happen. Around like 2 days, 3 days before the quiz, I'll tell you the ballpark of what the question is. That's what I always do. So you literally know what the question is when you're coming to the quiz. You prepare yourself for that, and you come to the quiz and you do it. Okay? That's why it's completely closed book. Everything, you have no references, nothing. You don't need anything. Practice it, see if you can do the quiz, and then you come and do it on your own. Okay? So quizzes are like that. Quizzes, midterms, exam, everything's like this. So I'll tell you what the questions are before you come. Of course, I'm not going to tell you word by word, but I'm going to tell you that you're going to write a move constructor. You're going to write a move assignment, things like that. I'll tell you what you're supposed to do. You go practice it, and then you come and do it. Got it? Okay, so you're going to get that, and it's going to be next one. Quickly going through what we have done last time. We talked about command line arguments and how main receives everything. argc is the number of tokens on the command line. argv holds an array of strings. The elements is the number of argc. Then there's a third one that is not in the notes, and you need to know that's going to be on the test quiz, whatever you have. So that's going to be the EMV that you have over here. EMV actually holds all the values that you have in the operating system. Now, I don't know if it was your class or some other class. I actually mentioned it's a good practice to go write a command that prints the contents of an environment variable. So essentially write a command that says EMV value. That's the name of the executable. So you say EMV value path. Then it's going to show you the content of the path or tells you that the content doesn't exist. It's a good practice. We said that all the contents that is coming to in the environment variables are in this format. So essentially you have the variable name equals to value. Okay? So you have to look for the assignment. Whatever you have at left side is the name of the environment variable. Whatever is at right is the value that is contained. And this is one C string. So this is essentially a C string. So a C string. When I say C string, what do I mean? What does it mean, C string? C string? That is? A character array is fine, but what is the difference between a string and a character array? Do you know, my lady? No, there's a specific difference. What is the difference between C string and a character array? Null operator. Null terminated. Null terminated. So you won this thing and keep it. So null termination. So essentially it's a null terminated array of characters. That's why it's called a C string, where a string in C++ is an object. It's a class that does stuff. It encapsulates a C string. So that's that. Anyways, quickly going through. We talked about size of an alignment. What is the size of a variable? What is the size of a compound type? And what does alignment mean? If any questions on anything, you stop me and ask me to explain. We talked about R value and left value. We essentially said anything that's standing at the left side of an assignment operator is an L value. Anything standing at the right side of an assignment variable is potentially an R value. It could be an L value too. L value can stand both sides. R value only at right side. Then we talked about A, B, C, D, E, yeah. So we gave you examples of R value and how we detect it using an R value reference. An R value reference accepts 2 ampersand. So if you put that one, it essentially picks up an R value if available, okay? If not, it works with this. So if I do not have this, yeah, that's it. So it picks up an R value. And 20 is an R value, and int x is an object that is about to die. That is considered an R value too. We talked about how to force an L value to impersonate itself as a R value. That's with the move statement. So move statement essentially, and it's a utility header file. So you put move around something, it impersonates it as an R value. As an R value. We talked about range-based loops, and we said range-based loops are essentially creating in a for loop a variable and a column name of an array. Essentially, you are saying assign this variable to an element of the array in every loop that you're going to the end of the loop. And that's what a range-based loop was. And we said that if you do not put a reference over here, it's going to be a copy. If you change it, nothing's going to change in it. We gave you an example with a reference. If I actually set that as a reference, then each value can be changed by changing the range-based loops element. So essentially, you'll find out that this is actually called an iterator. It iterates around the array. So the first thing that we write in a range-based loop is an iterator. It iterates around the array. So if the iterator is a reference, you can change it. If it's a value, you cannot. We talked about array initialization, and we said exactly what an array initialization is. If we don't have the size is that, otherwise, and so on and so forth. So things like this you know already. So we talked about classes in C++, as we know that they are encapsulation of data and behavior. We talked about class initialization, and we said when we have class initialization, essentially what you write as default initialization happens first. It will be ignored if you have a member list initialization. Member list initialization override the default initialization. Anything you do inside the body of a constructor is not initialization of the members, but it's the initialization of the class. So anything you write inside the body of the class is initializing the class. But the attributes of the class, too late. They are already created. You cannot initialize them. Okay? So if you want to initialize the attributes of a class, it's either in a default initialization or in the member list area. The order of the member list, we said it should match the order of the class itself. Otherwise, some compilers may give you warnings. We talked about action of moving. We said that if a class has resources, the action of copy and the rule of 3 that we have, that is copying an assignment. We know destructor is the thing, but copying an assignment is very expensive because it has to recreate each dynamic or resource that it has and copy everything. When an object is about to die, it doesn't make sense to copy it. It's better to instead take over its ownership. So we can actually do that using what we call move constructor and move assignment, additions to rule of 3 that makes it rule of 5. When you are doing a construction, you are literally setting everything and copying it as we specified in this example. But if you want to move it, then that copying doesn't happen. You simply say my attribute will point where your attribute is pointing. Therefore, you are pointing to the data of the other class. And now the other class doesn't need that, you set it to null. Therefore, the other class will lose its access to the data, you will gain the access to the data, moving completed, done. So when it's actually going out, the class is going to lose its data, and therefore the action of moving is much faster. Same thing with copy assignment, where we copy everything. So the logic for self-assignment and everything is exactly like copy assignment, but in move assignment, again, we take ownership of the data of the other, and we block the access of the other to the data, and therefore when the other is dead, there is no data that it can delete, therefore moving is complete. And that's the gist of all the moving. Moving semantics are much simpler than copying. With copying, you have to measure the size of the data, copy all the data, and allocate it and copy it and all the stuff. But with moving, all you need to do is to say, hey, your data is mine now. Done. You don't have to do anything else, so it's much simpler. And the process is exactly what you see in here. And that was the end of what we talked about last time. Now we're going to do a quick kind of glance on all the concepts one by one and continue. So close all tabs, but tool window. Close all tabs but this. All right. All right. So I think I actually ran this. Yeah, so it's good. So let me see. This is good. So this comes over here. Sorry, I'm just organizing the stuff over here. So let me double check. Actually, let me close and start from scratch. Okay, where did I put them? All right, so we need this. And this comes over here. There you go. All right. We talked about classes, constructs and initialization. We talked about move versus copying, which is essentially move versus copying. So we essentially said that whenever you are copying data, as you see over here, I have one single integer in this box of mine. I'm doing it with single. The other one was an array. So I have one integer that is the data of this box, and it's dynamic. If copying is happening, I create a new integer that is a copy of other data, and I hold its address inside data at line 7. But when it's moving, what I do, I simply set the address of my data to the other one and set the other one to null. So that's a simple, like very short version of moving that we have done in the other one. It's done all with initialization. So essentially, let me actually make it better over here so we can actually understand. So the data that you see over here, Control H, I'm going to change it to M data, so you know this is actually there we go. That makes more sense. So now I just wanted you to when I say M data, I'm in the member data. So essentially, I am initializing, when I'm actually creating at line 9, I'm initializing the data with a new integer and put the value in it. That's a regular constructor. With copy constructor, I am initializing M data with a new integer that is a copy of the other data. Therefore, that's copy constructor. With box, with move reference over there with other, I am initializing data, M data, with the content of the M data of the other, which means they both point to the same address. Then I make the data of the other one null, hence moving. That's the difference between moving and copying. This would be a good question for a quiz that I would say, okay, here's a copy thingy, do a move constructor for it. Sorry, do a move assignment for it. Or just give you that one and tell you, write the move semantics for this. Something very short and simple so you can demonstrate actually how it works, okay? So actually, let me write it down. You know that, man, I write it down so I remember what is a good thing for the quiz. So this file that is move example is a good thing for the quiz. So, oh, quiz question 345. So that is week 2 move example. So that's a copy move example. That's a good question for the thing. So as you see for the examples that you see, I create a box at line 23. I'm creating a box with 42. That's very, very fine. There's nothing wrong with that. Then I'm copying B to A, so that's copying, and I'm sure everything's good with that. But if I want to move one to another, I'm creating box C, and I'm going to say move A. When I put move reference over here, therefore the assignment is going to be picked up by moving, and therefore the constructor that is called is a move constructor, and therefore A will lose all its data, and it's moved to C. It's not going to have anything in it anymore. So that's that. All right? You want me to run it, or we understand what it is? You want me to run the example? Okay, sure. Okay, so when I run the example, so if I'm running the example, then I have to do this. Wait. It's compiling, sorry. Yeah, let me bring this down. It's bothering over there, actually, and annoying. All right, so I'm just going to bring this one down so it becomes a separate statement that is running so we can actually walk through it. The other ones are initialization, so let's stop and run it again. You know what I'm going to do? So for us to be able to see it properly when I'm walking through, I'm going to set this as null, and I am instead of initialization, I am going to set these things up as statements in the constructor. So I'm going to say mdata is equal to, it's not initialization anymore, but it's traceable. Like that, it would run as one statement, so you couldn't see what is being executed. Now all I'm doing over here is bringing all the initialization out. You see, you can do so many things in one line. I'm just showing to you what those things mean. Okay, so I'm taking this out too. Are we good? I think we're okay. If not, then we'll debug it. So let's do it. Now I'm going to go one by one and see what happens. Let's put this one at left and this one at right. Now let's go. So constructor is happening, comes over here. It first, as you see, because I'm not setting anything first, it makes the data null. The default is happening. Then it sets the value 42. So mdata is going to point to an address that is 42. Comes down. Now a copy constructor is happening. Assignment at the moment of creation. It first sets it to null. Then it sets it to new integer. Then it sets the target of that new integer to the target of the data of the other one. And therefore now B holds 42 as A had 42. Now it comes over here. Now moving is happening. When moving is happening, it goes to move constructor. Again, it's going to be set to null. Then it comes over here, it says I, that I'm not pointing to anything, will look at the address over here. It's 60. You see that? The address is 60. So as soon as I do this, now mdata is pointing to 602, that is 42. And I'm making the other one to be null. So the other one is not pointing to anything, where this one is pointing to 42. We come out, and now I'm going to show B, which has 42. I'm going to show C, which has 42. I'm going to show A, which is empty, because I just moved it into that one. And then I go out. There we go. OK? So that's literally move semantics. You can do it like this. But if you do it like this, you show this code to someone, although you did it right, they know you're a rookie, okay? Because all these things can be done through initialization. That shows you're experienced. That's the only difference between the two. We good? All right, so you know what I'm going to do? I'm going to stop there. Oops. I don't know what that thing was, but it did something. What did I do? What that circle did? I don't even know what it means. Anyway, so let me just run it, make sure it's good, because I clicked something else. I don't know what happened. OK, it's working. OK, so I'm going to go Alt-F-A. So this is going to be C, move, example, .cpp. OK, and I'm going to bring the other one. Control A, Control V. It is the exact same thing. And I'm going to call it B dash move example pro.cpp. Okay? So you know exactly the difference. They are exactly the same, but kind of written in 244 way or 345 way. Okay? Now we need to talk about static class members. So what was static? When we wrote static, so no, let's actually do this. I gave you an example about static. I'm just going to quickly static review. So we said if I create a static variable over here, and var plus plus like that and cout var. When I do something like this, if I call foo few times, what static variable does is that foo. What the static variable does is that it keeps the lifetime of that static var over there as, global. So the lifetime is global, which means lifetime is the lifetime of the executable, but its visibility is only in foo. That's what static was. So that we called a static local variable. That was one static. We good? All right? We know that. We already went through it. The second static was to prevent something to become global and enforce file scope. So if I wanted something to be only file scope, this is what we did. Static int file scope variable. So what happens over here, you cannot extern that. When you put static in a file scope variable, it forces it to be file scope. You cannot make it global anymore. You cannot have an extern for it. Okay? So that forces that static, when it's done on a global variable, forces it to be file scope and cannot go to another translation unit. We good? Okay? So this is the review that I had for statics that we talked about before. So CD, static review. The next one that I want to talk about is static class members. What does it mean when we have a static class member and static method? So when you create a static over here, as you see static counter, this is what happens. Let me explain. So when you create instances, so let me actually create something. Sorry. let me add something over here too. I'm going to call it integer attribute. Okay. So when you create something like this, let's say for this attribute thingy that you have over here, what happens is that when you actually create instances of your class, so I create 1 counter and 2 counters, 3 counters, and 4 counters. Okay? Then inside these counters you have attribute, 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 attribute. So this is your attribute. Okay? Now count over here is static. Static, what does it mean? It means you just create it once. Well, wait a minute. If it gets created once, it belongs to which one? The answer is no one. They share it. So your static member variables, which is this one, will be here. And they can be accessed by all. That's why another name for it is class variables. You don't need to instantiate the counter to see what is the value of count. Of course, because count is private, you cannot access it, but you don't need to instantiate it. It gets created. Because of that fact, you have to initiate its creation outside of the class. Any static member variable must be initialized outside of the class. You see that it says int counter count is equal to 0 at line 14. That's the initialization. You cannot initialize a static member variable inside the class because the answer for it is that which one is supposed to initialize it? It doesn't belong to anyone, so the constructor cannot construct it. Constructor is supposed to construct different instances, but because it doesn't belong to any specific instance, therefore it's not going to get created over there. So at line 14, you are supposed to actually set it to 0. So this line over here actually sets this thing to 0. Got it? Now, we have methods. We could have methods over here. So let's say if I have something like I can have a print method over there that prints the count. Can I do that? So essentially, this is my print. This is my print. Oh. This is my print method. I put green in front of it so we know that that's what it means. So this is print, this is print, this is print, and this is print. The question is, can these access the count in the middle? Yeah, the answer is yes. Of course they can. It's very obvious that they all can see the 1. There is no problem with it. Okay? So they can print it. But the question is that, can they change it? Can they change its value? Can they access it to change it? We need to know. So we're going to go through all that. Okay? So another thing that we have, the answer is yes, they can change it. There's no problem with it. But the question over here comes as this. What if I make a method static like getCount? When you make a method static, it becomes exactly like a variable. So that getCount of yours is created outside. Because it's created outside, it is obviously accessible to all these. So essentially in here, I could do there is no problem with that. Why? Because 1 can access the 1, which means this can perfectly access that one. There is no problem. But in getCount, can I print the attribute? Can I from here access this? Oh, attribute is the red one. Can I here access this? The answer is no, because there are 4 of them. Which one are you talking about? You can't do that. That's why you have to remember, this is extremely important. Static methods can access static variables, but not attributes, regular attributes. Non-static can access everything. Okay? The static attribute must be initialized outside of the class right after the class. So they exist and they have a value. Otherwise, you're going to get an error. You're going to say, hey, you have a static thing that is not set. Okay? And another thing that you need to know is that you do not need to actually instantiate a class to call the static methods or a static attribute, because another name, remember, static members are also called class members. So essentially, getCounter becomes a class method, as count is a class attribute. Therefore, at line 18, I'm saying cout getCount. I didn't even instantiate it. But what am I using to access it? The class and a scope resolution. The question is, can I say a.getCount? Yes, you can. Can I say b.getCount? Yes, you can. And also, you can use the class name to access the static variables. So static variables are not only accessible by the instances, but also they are accessible by classes. So in here, I can say cout a.getCount, absolutely no problem. Or cout b.getCount. So as you see, essentially the code we have written over here counts how many instances of the class you created. See, at line 19, I'm creating 2 of them, right? So when the constructor is called, it actually adds 1 to the count. So you can count how many, and the destructor is removed, reducing the count by 1. And that's that. Okay? So that's what static methods and variables are. And obviously, if I run this, you're going to see that's happening. I'm going to get some. There we go. Right? What we could actually do was this. I could actually create this one like counter and then pointer b. And the pointer b could be set as new counter. Counter. Okay? So, and in here now I could say, obviously I could say b.count. So the result is the same, but the cool thing is that now I can say delete b and then show it again. And it's got to be reduced back to 1, which means I created 1, now I'm deleting 1. What happened? Did I just write something wrong? Where is the F10? So let's create this and that. So B is actually pointing to, okay, get count is due, get count is due, get count is due. Oh, I'm a bad person, Delete B, sorry about that. I deleted an array by mistake. Delete, it's recompiling it. And then becomes 1, and then it goes out and everything's good. Okay, so this is better. All right. So let me start, end the drawing, clear all, and this one's going to be statics. So we have statics. All right. You can create anonymous classes. There's absolutely no problem with it. So an anonymous class is a class that doesn't have a name, and you can instantiate it right away. You can have it inside another class. There's no problem with it. So an anonymous class is this. You see, I create struct, I don't put any name, and I'm just going to instantiate it afterwards. Or you can actually use type def. This becomes a C style. In long time ago in C, for us not to rewrite struct, we used to do that, either using type def or that one. Or you can have classes like this. You can create, for example, class student. Then in the student, you're going to say struct string first, string last, and then you can say over here name. So having something like this, and then, I don't know, size T, student number. Okay? And whatever. Okay, so you can do stuff like this. You can actually create anonymous classes. You want to have a first name and a last name? You can do it like this. It doesn't matter. So name.first becomes the first name, name.last becomes the last name, but this thing is just a name, anonymous structure that you are creating in it. You can package stuff like this. If you don't want to create a name class, you can just do it that way. Okay? So these are anonymous classes. And then enumerations. So C language came up with this idea to create stuff for, create some kind of a construct that it makes our code more readable. Let me just point it to you this way. Say I want to have days of the week. So what do? You write enum weekday, enum weekday, and then you write over here Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So what does this do? It creates a type for you called weekday and creates 7 constant integers with values 0 to 7. So sun essentially becomes 0. Monday becomes 1, and it goes up to 6, that is Saturday. It just makes the code more readable. That's all. This comes from C. So now that if I have something like this, now I can actually write code like weekday W, then I'm going to say if, and whatever happens in here, it doesn't matter. Then in here I can say, I don't know, if W is equal to Monday, then I can start working. I don't know. That's enumeration, okay? So these are literally 0, 1, 2, 3, 4, 5. And you can, it becomes like true or false that you have values for it. It's set to constant integer values, okay? So I'm going to call it C enum. Another example for it could be something like this. Okay, same thing. Now I have color, and it's white, red, green, and blue. It's just enum. Now C++ made it type safe. How did it do it? It made it scoped enum. So scoped enum, what it does, it creates a class. And what it does, that it actually make those constant value part of the enum that you are creating. So when you create something like this, when you say enum class color, white, red, green, blue, they only have meaning inside the color scope. So white as a global thing is not, it's not identified anymore. It is within the scope of the color, and if you want to access it, you have to say color scope resolution white, and that becomes white, okay? The only thing that it does, it brings those values inside the scope of color, and therefore type mismatch won't happen. Let's put it that way. So Boolean that you use is a regular enum type of a thing, okay? But if we put it inside a class, then, yeah, anyway, so you know what I mean, right? So white by itself is not a global variable anymore, global variable that is constant anymore. If it's just enum, then these all become global constant variables. But when you actually put class in front of it, they become part of the color scope, and therefore make everything more type safe. C++ scope enum. Okay. It's the 3:15. So take 5 minutes break. I'm going to prepare something, and then we're going to talk about inheritance polymorphism, class templates, and composition and relationship between classes. Okay? wanted to have this as separate things. It became too many files, and it just, I'm going to just do it at one. That's going to be simpler. So let me continue this. Okay. So talking about, now we're going to talk about inheritance and inclusion polymorphism. Quickly going through it, we've already done this in OOP345, so you know exactly what we have over here. The only thing that I added over there is the function clone, okay? But the rest of it you already know. So giving you an example of what inclusion polymorphism is, that you usually have an abstract base class that, in this case, this is actually an interface. An interface is an abstract base class that has everything as pure virtual. So it has two pure virtual methods. One is a double that calculates what the volume of the shape is, and the other one, it clones the shape. Now we'll come back to clone and see what is the purpose of it. When you are, the next one we are creating is a cube that is essentially a shape. It has a length, and that's the only thing the cube needs. And it constructs it by setting the length, and the volume is the length multiplied by length by length. We know that. And when it clones, it creates a new instance of its own dynamically and returns it. Look at the clone over there. Okay? It is returning a new cube, but what is being returned is a shape. It can do it. Why? Because cube is a shape. We okay with this? The same thing what we are doing over here with the sphere. So a sphere, we're going to say it has radius, and we're going to set it with the radius, but the difference between the volume of a sphere is that the radius multiplied by radius by radius must be multiplied by 4.18879, okay? And that becomes actually the volume. How it clones itself, it works almost like the sphere, well, like the cube. It creates a new sphere, dynamic, and returns it. Why did we do it? The reason is this. Imagine when you create an instance of type sphere, and you are actually passing it to display volume over here that is a shape, okay? Now, imagine if I wanted to make a copy of the shape in here. How could I do that? If you pass an object that is inherited out of an abstract base class, and you pass that object to a function using its basis pointer, when you go in there, if in display volume in here, I wanted to make a copy of the shape, how could I do it? It was absolutely impossible, because you don't know what is the shape. How do I make a copy out of it? A copy is not going to work for it. That's why creating a function called clone is a standard. You do like that, and you make that one virtual. Therefore, when shape says clone, then the proper clone will be called automatically. So in here, if I wanted to, for any reason, if I wanted to make a copy out of it for any reason, I could simply say shape. Actually, it's a constant one over here. I can't do it with const, so void make copy. And in here, I'm going to have shape. Actually, I can do the clone too. That's okay. So in here, I'm going to say shape pointer s equals to shape clone. So what it does, it actually gets that one. Now I can actually take the s, that is a copy of that clone, do copy of that shape, and do anything with it. So that display, if it's a cube, it's gonna, well, be a cube. If it's a sphere, it's going to be a sphere, and everything is fine and dandy. So, so in here, let me create another shape. So I'm going to create shape 2. And I can make this one a cube. Okay, and in display over here, let's say I want to show the copy over here. So I'm going to say S volume, and at the end when I'm done, I'm going to say S dot, delete S. Okay, so, and in here, shape 2. And delete shape. Yeah, so anyways, clone does that. So it's just be aware of it. Let's put it that way. I'm just going to run it to see if it runs. There we go. So one is the cube and the other one is the sphere. Okay, so I'm going to go GHI inclusive. Okay. The list of substitution principle says that functions using base class, references, and pointers should work with derived class without knowing it. What does it mean? Take a look. Let me create, let me show you an example. I create a class rectangle with width and height. Then I create a square out of like a rectangle, and I say essentially the set width of I have a set width and a set height. And what I'm going to do is simply say, if you are calling set width and set height, because square is the same, I'm going to set both of them. So I'm forcing a rectangle to be a square. So inheritance is happening from a rectangle to a square. And when I set rectangle to whatever I want to, everything is good. But the problem is that if I actually want to work with a square as a rectangle with different width and height, because it has them both, it's going to fail because the inheritance is done incorrectly. When you are working with a square rectangle, you need to know, when you're working with a square, you need to know if the width and height are the same or not. So you have to literally know what it is inherited from, and vice versa. And that's not right. Because of that, the proper way of inheritance over here would have been EFGHI the proper way of doing it was to do like this, to create a square as a base, and I say rectangle is a square that has a height. Now everything is set. Now none of these need to know what the other ones is, and everything worked perfectly. A square works as a square, rectangle works as a rectangle, and no difference is made. You have to always remember, when you are doing inheritance, everything has to work independently. If you need to know what something is supposed to be driven into or derived from, then your design is not right. Okay? This is extremely important. And that's the and that is the Liskov substitution principle. And after that, we are going to talk about templates. In OOP345NRA, we talked about function templates, and everything was fine and dandy. So essentially, templates are what we call it parametric polymorphism. With inclusion together, it's the universal polymorphism that we had, right? So with templates, what we did with the functions essentially was to create something like this. We had a return type, we had a function, and we have some parametric things that are coming in, and we made a function template out of it. So for example, if I had a template like this for swapping, okay, I could use that template in a function and why does it give me an error in here? Sorry, we have a swap already. That was a name conflict. So what happens when you create the template? When you create a template, no code is generated by the compiler. Compiler will generate nothing. As soon as you call it, the compiler notices that it's needed, therefore the code is created at compile time. If I do not call the swap for long, only one swap will be in my binary. As soon as I call the second one, compiler finds it necessary and rewrites it. So every template is rewritten for us at compile time. When compiler compiles your code, sees how many calls you have done with the template, using the code of template as we learned from OOP345, it simply regenerates it. Done? Okay? Now, because of this fact, you cannot have template modules with header file and a CPP. Because if you want a template to be used in a CPP file, you have to include the template as a header file. If it's only the prototype of a template, then compiler has no access to its implementation to be able to generate it. Remember, modules are compiled separately. Because of that fact, all template modules exist only in the header file and nowhere else. You don't have a CPP file for templates. They are always entirely in the header file. And that's why the compiler can actually generate them. Okay? So that was a function template that we've done. Now, we need to understand what is template specialization. So if I want to find the maximum of two things, normally when we do that, we can use this greater than sign and find out which one is maximum of which is very fine. The problem is that when we are dealing with C strings, I have to do a string compare. It doesn't work with greater than less than. To specialize it, what I can do over here is to create another template, but do not mention any type in it, which means I'm telling to the compiler the type is about to come. This is not a general template. It's not for everything. It's a template that only applies to one type. How do I specify that type? Right after the name of the template. So if this is a maximum template, this indicates what type needs to trigger this, which in this case is a constant character pointer. Therefore, where maximum with constant character pointer is called, this template is ignored, and this one is used to generate it. So as you see over here, the templates over here, there is nothing between the name and the arguments that are passed. In specialization, we leave the template empty, and whatever we put between these, the name and the parentheses, dictates what type this template is generated for. Now, there is a catch for this. We could always, instead of doing that, we could always create an overload instead. Because overloading works with templates. If I just overload the maximum, when this is called, compiler looks, oh, there is a function for it. There is no need to go to the template. Overloads always supersede the templates. Because of this fact, when the templates are created, so the overloads are created, the template is ignored. There is one problem with this. The problem is that the whole purpose and reason of having a template is ignored. The whole purpose of having templates is that when it's not called, I don't want the binary, the executable, to hold that function. If I do not have line 22, which is a call to maximum between two constant character pointers, still the compiler will compile my function and it will exist in my binary. The whole purpose of templates are done. Templates are created, so if you don't call them, they're not going to get compiled. They're not going to get generated. Because of that, although it works, more professional ways to always specialize it. Because when you specialize it, if you don't call it, it's not going to get generated. Does that make sense? Hopefully? Okay, so remember, overloads. So you can use overload instead of specialization, but then the function will always exist in the binary. Okay? Where if you have used specialization, it wouldn't have. Okay? So I'm going to comment this and uncomment this one because this is the good one. Okay? We good? Function template specialization. Sure. Okay. class templates. Like functions, you can actually create templates for classes if you want to. There is absolutely no problem with that. There's only a few things that you need to remember. A few rules, actually. Okay? So a very simple example that is in the book is this. So you create an array, and any part of the array that you want to you create a class, and any part of the class that you want to change based on what the template is, you change that. For example, if I want to create an array of 50 things, I can say create a template T and create a class called array. Now that array will be an array of 50 t's. Now, whatever t is, if it's integer, it becomes 50 integers. If it's a double, it becomes 50 doubles. And anyways, as you see, that there's an operator overloaded for it to just give some value. If it's less than 50, it's going to give the value out. If it's not less than 50, it's going to send the dummy value out. So I'm creating it safe. It's kind of a 50 things. The catch for it is that unlike functions, classes don't have signatures. If I say over here array A or array X, how do you know what is X? Array of what? There is no way to have signatures for this. Because of this fact, class templates always carry the signature of the template right after the class name. If I want this to be an array of integers, I will write over here integer X, or array int. So essentially, now I mean the t over here is supposed to be replaced by an integer. If I want an array of doubles, I will say array double D. If I want an array of employee, I'll go array employee E. Got it? Is that clear? That's how they are created. Now, this is a very simple and straightforward thing. But there are certain rules and regulations attached to arrays, to class templates, that you need to know when you're actually creating a class template. And I'll explain them to you one by one as I go through it. Let me just... so for now, what I'm just showing you is syntax, okay? I'm not telling you how to create a class template yet. Please just understand the syntax for it, all right? So the main for this could be this. So that creates an array of templates, and I need IOStream. Again, please note that this is supposed to be entirely in a header file. And it should be actually including the array.h, okay? You can not only pass signatures to class templates, but also you can pass regular stuff. So, for example, you can do something like this. As you see, now I'm saying template, type name is T, and int size. So when I'm actually creating this, I can say array, double, and 100. So essentially, I'm saying create an array of 100. So it passes the size to the array when it's creating it. Okay? Those are values that you say. They call it non-type template parameters. Those are called non-type template parameters. Not only that, you can actually add default values for it. So if you create it, like you say, if I want to create an array, by default, I want the array to have 50 elements. So if they don't mention, it's going to be 50. If you mention it, it's going to be whatever. So that's that. So the default, you can have default values for it. Default value. If you create static members in templates, you must instantiate them using the signature. So essentially what happens over here is, just a second. So in here I have the template type and size and stuff like that. And as you see, I have a count over there is static value. You have to initialize the static value out there because that static value is going to be different for different types of templates. The initialization line must carry the template signature at the top. So you have to say for template type name T and int size, unsigned, and then you put the value over there like that. So what happens is that for each template class that is creating for a new type, it's going to create a separate static variable for it. And that is the syntax for it. Okay? Again, we are just talking about syntax here. I'm going to show you a practical one, actually how to create it, and you'll see things are going to make sense, hopefully. Okay? For templates and inheritance, it's pretty straightforward. Statics and statics and templates. For inheritance, it's obvious. When you have a class that is a template and you want to inherit it, you have to pass, when you are inherited, you have to pass the signature to the base so it knows which one it is inheriting it from. It's as simple as that. So when you are inheriting a template, you must pass the signature to what you are inheriting from so it knows which one it belongs to. Okay? And you can actually hard code. So it's completely straightforward. Anything that you're inheriting from, you have to pass the signature for. So this is the one. All these informations are passed because we assume that we know what inheritance and everything is from OOP345. Now, this is what I'm going to do. I'm going to talk about relationship between classes, okay? Because it's something that I can cover in 10 minutes. The next day you are coming in, please go through all this syntax mishmash. I know it's crazy when you're going through it, you don't understand what's going on. So the next day you are coming in, I'm going to write it over here. So for NRA, I'm going to, and please remind me of it too, to start with class templates. Template example. Okay? So what I'm going to do, I'm going to actually create for you a proper class template and tell you the tricks about it, how you actually can successfully create templates of your own. This is not in the notes, but I'm going to do it properly so you'll see exactly what it is. Okay? So talking about relationship between classes, we need to understand what composition, aggregation, and association is. Okay? Composition, aggregation, and association. So I'm just going to tell you what it is and give you little examples for it. So composition. Composition, now you need to listen to this, okay? Composition is when one class is built up of another type of class. Think about a house and its rooms. A house cannot be a house without the rooms. It actually created, it's built up of different types of rooms. Living room, dining room, kitchen, washroom, powder room, bedroom, right? And in composition, if you take these classes outside of the composer, they don't mean anything. Can you go in a street and say, look, a bedroom? Impossible. You cannot have a bedroom standing by itself outside of a house. You follow what I'm saying? So a composition is essentially, a composition is like an array and its elements. An array is built up of its elements. If you take the element away, array will lose its meaning. And an array cannot exist without its elements. Also, an element by itself cannot stand alone. You cannot say, that's an element. Element of what? That is called a composition. Okay? So, a composition controls the lifetime of its composed material. When you remove an array, all the elements are gone. When you demolish the house, all the rooms of the house is gone. Are we okay with this? Now we have another type of things called aggregation. Now when two things are in aggregation, it's like a composition but weaker, which means the aggregator does not manage the aggregated items that is built up of with respect to lifetime, which means those things that are in aggregation with something else, it's like a club and its members. When you have a club and members have clubs, a club is essentially built up of its members. But when you destroy a club, the members are not dead. They're going to still exist. They're a completely separate entity. But and I can be a member of a RC club and a member of a book reading club. I can be a member of two different places. Nobody forces me to be just a member of one place, right? This is aggregation. The other one is association, which means neither is dependent to each other, like a teacher and a student. I can say I have 20 students, but if I'm gone, you remain as a student, I remain as a professor. A professor can be a professor without any students. I'm still a professor, I don't have any students. And a student can be there without any professor. If you don't take any courses, you don't have a professor. This is called association. So they're going to ask you, how many professors you have? I have 3 professors this semester, or 4 professors this semester. They tell me how many students you have. I have 200 students. But the relationship is just an association between us. Do we understand these? That's essentially what it is. Composition, strong. It owns, it generates its parts, and it destroys its parts. Aggregation is like composition, but it doesn't generate its parts. Association, they have nothing to do with each other. They're just in relationship with each other. Clear? Yeah, I told you I can tell you in 10 minutes, even 5 minutes. But anyways, so I have examples for it. I'm going to leave the examples in the notes. So essentially, there we go. So I can have a class. So this is a class name. And a person. A person is in composition with a name. You cannot have a person without a name, and a name by itself doesn't mean anything. I cannot say, Fred, that's a name. Name of what? Who? It needs to belong to something. So person and a name, that's a composition. Now, the composition that I create, what I would do, like if this is an example that I think I got from the notes. So with the example that we have over here, a person actually, what shall we call it? A person has a name, but this name is public. If I would create this, I would make the class completely private, that it cannot be instantiated. Then I would actually create over here a class, a forward declaration for person, and I would make that person a friend of a class. That's the true way of creating composition. Now, name cannot get created on its own. Only a person can create a name when it's being named. And it kills it when it's done. The name is gone when the person is gone. Are we okay? For the rest of the stuff, I'm going to put it on. It's 3:15. We have to leave. Intense amount of information got in. We are to date with our weekly stuff. But the next day you are coming in, I'm going to still talk about templates and give you some examples, some high-end examples of composition and association and aggregation, so you can see what it is. Just to go home and browse it and see what OOP345C++ code looks like for these stuff. Anyways, I'm not going to post the last one. I'll bring a proper example for it. I'm not going to save it. Please go through the notes. Everything in a note, read it, so the next day you are coming in, you can come with questions, and then we can start a new day. Have yourself a beautiful day, and we'll talk soon. Questions. Sorry, I forgot to ask. Suggestions? With the headphones on, I'm gone. Okay, have a good day, everybody. Bye.